Hi students. So now we've studied so many things. We've studied the early classification of elements by Brina. We've studied about Newland's octaves. We've studied about Mendeleevs periodic table, and we've even studied about the modern periodic table. Let's take a look at the summary of the periodic classification of elements, and let's look at how the periodic table evolved over the centuries. First of all, we started with Dobrina's triads. In 1826, Dobrina proposed that all elements, could be divided into groups of three called triads. Each of these groups of three had similar properties. Dobrina classified three triads: lithium, sodium, potassium, calcium, strontium, barium, and chlorine, bromine, and iodine. All the members of a triad had similar properties. He also noted that the average atomic weight of the top element and the bottom element of a triad was equal to the atomic weight of the middle element. So the atomic weight of lithium and potassium, when added and divided by 2, gave the atomic weight of sodium. The problem with Dobrina's triads, however, was that he could identify only 3 triads. Obviously, 3 triads means 9 elements, so there was some problem because we have to classify much more than 9 elements. Next in line were Newland's octaves. Newland's law of octaves said that all elements could be classified in the order of increasing atomic number in such a way that when all elements were grouped in the order of increasing atomic number, then the 8th element would have similar properties to the first element. Understood? So if you started from hydrogen, which had the least atomic weight, and you arranged elements in the order of their atomic weights, then every 8th element and the first element would have similar properties. So Newland said that this was similar to the law of octaves of music. In music also there are 7 notes, and the 8th note is a repetition of the first note. The problem with the law of octaves, however, was that only elements up to calcium actually followed Newland's law of octaves. After calcium, the elements placed one above the other, every 8th element, did not match with the properties of the first element. Understood? It was followed only till calcium. The second problem was that Newland had to sometimes group more than one element, in one single spot, so as to make sure that the 8th element followed the properties of the first element. So he could not explain why he had to group 2 elements in one spot. Another problem was that cobalt and iron had similar properties, but they were placed far apart in Newland's law of octaves. Therefore, we needed yet another periodic table. This periodic table was Mendeleev's periodic table. It came up in 1872. Mendeleev classified the 63 elements known by 1872 on the basis of 2 things. First, he arranged elements in order of increasing atomic mass, and the horizontal lines in which he arranged elements were called periods. Then he placed all elements with similar chemical properties one below the other. Understood? Similar properties were the formulae of their oxides and hydrides. So this was Mendeleev's periodic table. The horizontal rows were called periods and the vertical columns were called groups. In the horizontal rows, he placed elements in the order of atomic mass, and in the vertical columns, he made sure that elements with the same formulae of hydrides and same formulae of oxides were placed. Understood? So this is how Mendeleev classified his periodic table. Mendeleev's periodic table had many advantages. One of them was that Mendeleev made space for all those elements which had not yet been discovered. He did not try to fit in all the elements discovered till date in his periodic table. He left gaps, for example, for scandium, and he called it icaboron. Scandium had the same properties as boron. It was placed in the same group as boron. He called gallium ica-aluminium, and he called germanium ica-silicon. Germanium had the same properties as silicon. Mendeleev even predicted the properties of these elements, and they turned out to be very similar, to the real properties discovered later. Mendeleev's periodic table, was also easy to adapt later because the noble gases could be easily placed, to the right of Mendeleevs periodic table. An extra group could be added without disturbing his original table of elements. The problems with Mendeleev's periodic table, however, were that isotopes could not be adjusted in Mendeleev's periodic table. Chlorine has 2 isotopes, so which of the isotopes was to be used, in the periodic table, 35 or 37? Similarly, another problem with Mendeleev's periodic table was that some elements were not placed in order of increasing atomic weight. Cobalt has a greater atomic weight than nickel, but Mendeleev placed it before nickel. How could that be? The position of hydrogen was also not clear in Mendeleev's periodic table. It had the properties of group 1 elements and also group 7 elements. Where should it be placed? The modern periodic table solved all these problems. The modern periodic table was proposed by Henry Moseley. This is the modern periodic table. In the modern periodic table, elements are arranged in the order of increasing atomic number because atomic number is a more fundamental property than atomic weight. So from left to right in a period, the atomic number increases. There are 18 groups and 7 periods in the modern periodic table. In the modern periodic table also, elements placed one above the other have similar properties. In the modern periodic table, the valence electrons of each element increase by 1, as you move from left to right in a period. The number of shells, however, remain the same. On the other hand, when you move from top to bottom in a group, the number of shells increase by 1, while valence electrons remain the same. Since the valence electrons are the same, that is why all the elements in a group have similar properties. Another interesting fact in the modern periodic table is that number of elements in a period is the same as the maximum number of electrons in a shell. So for example, the second period has 8 electrons maximum in its valence shell. So there are 8 elements in the second period. We also discussed some trends in the periodic table, in the earlier chapters. Take a look at the valency of elements. As you move from left to right in a period, valency first increases and then decreases. The maximum valency is 4. Valency is the number of electrons lost or gained in a chemical reaction. Down the group, valency remains constant. In the first group, the valency of all elements is 1. The atomic radius is another property. It decreases in a period. As you move from left to right, atomic radius decreases. Similarly, as you move from top to bottom, the atomic radius increases in a group. So in a group, atomic radius increases, and in a period, it decreases. The metallic character decreases as you move from left to right in a period. The metallic character is the tendency of an element to lose electrons. That tendency decreases as you move from left to right. The metallic character increases as you move from top to bottom in a group. So bottom group elements have more metallic character, more tendency to lose electrons compared to top of the group elements. Similarly, the non-metallic character, the tendency to gain electrons in a chemical reaction, increases as you move from left to right. So elements on the right have greater non-metallic character compared to elements on the left. The non-metallic character decreases as you move from top to bottom in a group. So elements at the bottom have lesser non-metallic character compared to elements at the top. In fact, this is the line, this blue line here, that separates metals and non-metals in the periodic table. Some elements which are present here along the blue line, like boron, silicon, germanium, are called metalloids. They have properties of both metals and non-metals. Metals form basic oxides. So oxides of elements to the left of this line are basic, and non-metals form acidic oxides. So oxides of elements to the right of this line are acidic. So these are some important trends in the modern periodic table. So we learnt how the periodic table evolved, first from Brina's triads, then Newland's octaves, then Mendeleev's version, and then finally Henry Moseley's periodic table, which we use today. Hope you enjoyed this entire chapter. Let's move on to the next one.